Okay, so now what we're going to do is we're going to kind of go backwards from our last video. We're going to write equations given their zeros. So here we have a cubic polynomial in standard. We want to write it in standard form that has these answers of x equals -2, x equals 2, and x equals 3. Cubic means that we're going to have our highest exponent is going to be a 3 on x. So our factors, if I add 2 to both sides, x plus 2 would equal 0. I minus 2 here. And then I'm going to minus 3. So our factors would be x plus 2, x minus 2, x minus 3. All right, so we're going to write it in factored form. And to get standard form, we're going to multiply this out. You could use a box, or you can FOIL, distribute. So I'm going to pick 2 of them to do first. I'm going to do the first 2 together. Okay, so x times x, x times -2, 2 times x, and then 2 times -2. And then I'm just going to bring down this one for the time being. Combine like terms. So we have x squared. And these two make 0. X minus 3, I just brought it down. And then I'm going to multiply again. X squared times x, x cubed, x squared times -3, -2 times x, -2 times -3, so plus 6. Combine like terms, if we have any, and we do not. So because the exponents are all different. So here's my equation. I don't have any more like terms to combine. So is it a cubic function? Yeah, x cubed. Okay, so there's our equation. Let's look at another example here. Here, what I would like for you to do is look at these graphs that were graphed on a calculator, and f of x is the cubic function because it's a 3. So this is my f of x, and g of x is x to the 4th, and so here's what it looks like. And what we want to do is just kind of compare with these graphs. So let's first look at their in behavior. So this one is down, and this one is up. This in behavior is up and up. All right. And then let's also think about their leading coefficient. The leading coefficient. So typically, if you look at the notes that we had with our in behavior notes, usually a cubic, which is a odd function, would normally start down on the down and then go up. So that would mean that it has a positive leading coefficient. This one is going up in both directions, obviously because it's an even degree. And if it's both pointing up, it also has a leading coefficient that is positive. So in that respect, they have a similarity. Let's look at our x-intercepts. This one has an x-intercept at -2 and at +2 and at +3. It's a cubic function, so we better have 3 answers, right? 3 solutions. Let's look at the x-intercepts. On this guy, it's at -2, x equals, I should say, x equals 2, x equals 3. So it has exactly the same x-intercepts. But wait, there's a problem. This is a 4th degree. I have to have 4 answers. I don't have 4 answers listed. So what's happening? Perhaps we have some multiplicities. Let's go back and look at our graphs. Do we have any bounces or inflection points on over here? No. Do we have any bounces or inflections here? Yeah, right here. So at -2, it has a multiplicity of 2 because we need one more solution. So it's like x equals -2, x equals -2 again, x equals 2, x equals 3. So even though it has the same x-intercepts, the second graph g of x has a multiplicity. Very, very interesting. And on your writing prompt that you will be doing either Monday or Tuesday before Thanksgiving, I will ask you to do something very similar to this example. So I would maybe star this and go back and see how I compare and contrast those. Okay. All right, in example 3, a polynomial has these zeros, and we're going to write an equation in standard form. So we have answers x equals 3 and x equals 2i. That's imaginary. I can't have one imaginary root. They have to come in conjugate pairs. So what is the conjugate of 2i? -2i. They will not always tell you in the problem it's conjugate. You're expected to know that you have to include the conjugate. I have seen that on the EOC before. I've seen it on your unit test, multiple choice test. I've seen it over and over again. It's on your transfer test. You are expected to know that the conjugate is also included. So you have to pull that from yourself. So our factors. So x minus 3. I'm going to minus 2i from both sides. I'm going to add 2i. So our factors are x minus 3, x minus 2i, and x plus 2i. And now we're going to multiply. So this is factored form. And they want it in standard form. So we're going to have to multiply this thing together. Now, I will tell you that it is, do yourself a favor and multiply the two conjugates together first. Just makes life so much easier on yourself. So x minus 3. And now I'm going to multiply these together. You could do the box if you want to. It's just an organizer. That's completely up to you. Or you can just FOIL it, distribute. So x times x, x squared, x times 2i, 2xi. Yes, that's a thing. And then negative 2i times x. And then negative 2 times a positive 2i is a negative 4i squared. We're going to try to clean some of that up. Well, these cancel out because we multiply conjugates together. And we should all know what I squared is. Right? X minus 3, x squared. And I'm just going to rewrite on top of this. I squared is really negative 1. So that gives me a positive 4. Now I'm going to multiply by FOILing again. Again, you can do the box if you so desire. So x times x squared, x cubed, x times 4, 4x, minus 3x squared, minus 12. And then we want to just kind of clean that up, rearrange it so it's in standard form so that we go in descending order with our exponents. So x cubed minus 3x squared, 4x minus 12. So there is our function. Don't forget to do your Google form.